As you can see, when the light sensor is exposed to light, the color of the background lightens from purple to pink. Also, the particles change direction depending on the light level. If there is no light, the particles will remain on the left-hand side of the screen, and when light is exposed to the sensor, the particles move to the right as well as increase in size. Wires were used to connect the components on the breadboard to the Arduino. The 10K resistor will power the light sensor and give higher sensor readings. The light sensor will read light levels to manipulate the image. I connected the light sensor to the end of the wire so I can control where the sensor goes, thus making it interactive. The breadboard is used to insert the electrical components to connect it to the Arduino, which will read the input values. This diagram shows what components were used to create this project. The wires connect from the breadboard to the Arduino, which passes the input values to be read on the application. This is the Arduino code for the project. Defined light sensor A5 means the light sensor is passing its input to the A5 port on the Arduino board, which is being identified here. Serial begin 9600 is the serial communication that Arduino uses to send out commands through the USB connection. The data is being sent out 9600 bits per second. The input from the light sensor is an integer which is read from the A5 port. It will then print the values to the serial monitor. The delay is 100 milliseconds, which is how long the program waits to show the next line of code. There are three variables called light level, which will be used to control different aspects of the image. The first, light level, will determine the position of the particles. The second is used to control the speed of the particles. And the third is used to control the color of the background. This is the processing code which connects to Arduino to use the light sensor. Import processing serial is used to import the values coming from Arduino. Serial SER is used to connect the serial from the light sensor. The three light levels are declared as well as the classes needed to make the image. This is the setup of the image. The size of the canvas is 800 by 800 pixels. String port name is used to identify the name of the Arduino port, which will be used to connect to the serial. 9600 bytes per second is the rate at which data is being sent through the port. Void serial event is the class which will be used to map the light levels. Serial SER is being used in this class, which is why it has been declared. Integer.parseInt is used to change string values to an integer. The light levels are then mapped to the values needed to manipulate the images in processing. For light level 1, it will take the values from 100 to 650 and map it to 0 to 640. This is to fit the particles in the frame because any higher or lower and the particles will not be in the frame. Light level 2 takes values from 0 to 300 and maps it to 0 to 1.2. The level of light needs to be delicate since the particles will be too explosive if the readings are too high. Void draw is where all the control of the image takes place. The background has light level 3 in it, which will take light levels from 0 to 1024 and map it to 0 to 500. This will be the color gradient from blue to light pink. Usually, the particle is controlled using the mouse. However, I swapped the x-axis on the mouse to light level, which will use the sensor's light values to determine the position of the particles. Also, light level 2 takes values from 0 to 300 and maps it to 0 to 1.2. I use this variable in the speed of the particles, so the more sensor is exposed to the light, the faster the particles will be. The initial project had the light sensor connected to the breadboard. However, this made the project boring and not interactive enough. This was my first attempt of using the light sensor to manipulate an image using Arduino and processing. This is an image representing the process of soldering the light sensor to longer wire.